Hey guys, this is lesson 1.3 for algebra. It's exploring real numbers. Now, there's quite a few vocabulary terms because it's all the different types of numbers that are out there. So, first we have natural numbers. Natural numbers are, pretend it's like your age, how old you could be. 1, 2, 3, 4. It's all those numbers. You never say I'm 0 years old, or you never say I'm -2 or I'm 5.7. It's all just the straight numbers from 1 on up is natural numbers. Whole numbers, however, include 0. So whole numbers include 0, and then integers are all the negative and positive whole numbers. But notice, these all have just a solid dot because it is only the number. It is not any of the decimals or the halves or the 0.45s that go with the number. It's only the solid number. So those three are just those solid numbers. And I kind of like the number line. You can kind of tell the difference between the three. Now, a rational number is any number you can write as a fraction. So A over B. So the number 2 is also a rational number because I can write it as 4 over 2, 6 over 3, 8 over 4, all those different ways. But then the number 1/2 is only the rational number in this instance. So like 1/2 wouldn't also be a natural number or a whole number. It would just be a rational number at this point. Now, an irrational number is any number that cannot be expressed as a fraction. So, now, everybody knows the number pi, which equals 3.14 da 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 da. That is an irrational number. I think of irrational as crazy. Like if you say someone is irrational, they're crazy. And so any number that has a crazy ending, like 2.7413278642, all those ones that have no pattern and just are crazy at the end, those are irrational. Now, real numbers this is a set that combines both the rational and the irrational numbers. So pretty much every single number is a real number. But it's not any of these at the top. Well, it is these, but it also includes all the numbers in between. So real numbers are all the numbers, all the rational and all the irrational. All right. Any example that proves a statement's false is a counterexample. You need only one counterexample to prove that a statement is false, while a proof to show that a statement is true may be more complicated. So, is each statement true or false? If it is false, give a counterexample. So, try these two problems, and then we will go over them. Okay, so all whole numbers are integers. So if we look back at our definitions, whole numbers, are all these whole numbers integers? So if you look at this, is 0 an integer? Yes. Is 1 an integer? Yes. Is 2 an integer? Yes. Is 3 an integer? Yes. So yes, that is true. All whole numbers are integers. If false, give a counterexample. We don't need to do that because that one was true. No fractions are whole numbers. So if we look at our whole numbers, like I said before, if you remember, no fractions are whole numbers. It's kind of true because if you simplify a fraction, it can be written as these whole numbers, 1, 2, and 3. However, if I wrote the fraction 6 over 3, that is a fraction, and it is a whole number. So this is false. And then I just gave my counter example above. All right, 3 more definitions, and then we're done with the vocab for this section. An inequality, these are all pretty simple. An inequality is a mathematical sentence that compares the value of 2 expressions. So, what they want you to do in this lesson is to write these fractions, 1/12, -2/3, and -5/8 in order from least to greatest. So try this problem, push pause, and then we'll go over it. Okay, so if I look at this, I automatically know that these two are going to be my least because they are both negative. So then you have to decide which one is smaller. So if I look at 2/3 and I do this real quick, I could do this 3 divided by 2. 3 can't go into 2, but 3 goes into 20. So then I make a decimal. 3 goes into 20 6 times, which is 8, and then I have a repeating decimal. So I know that's 0.66, which I'm sure all of you know off the top of your head anyway. Now, 5/8, if I do that, so this is -0.66. If I do 5/8 and do 8 into 5, that doesn't work. So then 8 goes into 50. Well, 8 times 6 is 48. So they're pretty similar right now. And then I bring down a 2. 8 goes into 20 twice. So this is -0.62. So then I look and I see, okay, well, if it's negative, I want the one that's bigger. So I want the one that's bigger, and that's actually smaller. So -2/3 is my smallest because it's closer to -1. And then -5/8, and then 1/12. From least to greatest. All right, 2 numbers that are the same distance from 0 on a number line but lie in opposite directions are opposites. So -3 and 3 are opposites. So just write that down, opposites. And then absolute value of a number is its distance from 0 on a number line. This should all be a review. So try these 4 problems and then we'll correct. All right, the absolute value of 5 is 5 because it's 5 steps from 0 on a number line. -4 is 4 because it's 4 steps from 0. The absolute value of -3.7 is just 3.7 because it's 3.7 units from 0. And this is 5/7. Very simple. Okay, explore the difference between rational and irrational numbers. Which numbers can be rewritten as a fraction of 2 integers where the denominator is not 0? So what does this mean? All right, so if I look at these numbers, try to pick out the ones that are rational and the ones that are irrational. All right, so if I think about my rational numbers, that means they have an end or a pattern or they're a whole number. So I know that this is a rational number because it's 100, -100. 6 is also a rational number. 0.37 is a rational number because it's a decimal that ends, it stops. And 1/2 is a rational number. Now, if I look at pi and I wrote it out, 3.1417526, I'm totally guessing. That is irrational because it has no pattern. So this is irrational. Now this one looks like it has a pattern, 101000100. It does have a pattern, however, it's not the same pattern. If it was 0.10101010, that would be rational. However, it's not. So that is irrational. And then the square root of 3. That, if you put that into your calculator, is an irrational number. It comes out with a decimal that has no pattern. So there is quite a difference between the two. All right, that is it for your notes.